When systems engineers first configure a real-time voice AI, they usually rely on a very human instinct, over-explaining. They assume that feeding the model exhaustive details, edge cases, and caveats will guarantee stable, predictable behavior. In reality, narrative-style prompts actively degrade performance. When an AI processes long, sprawling paragraphs, it struggles to isolate the actual commands from the descriptive filler, leading to erratic logic during live calls. The language model operates within a strict limitation called a context window. This is a finite amount of active memory. Every unnecessary word you write consumes a token, crowding out the space the model needs to process the caller's actual request. English is just the interface here. A system prompt is code. It must be treated with the exactness of an executable script rather than a legal contract or a piece of creative writing. To achieve deterministic routing in real-time voice, engineers must abandon paragraph-style writing entirely. The solution is formatting prompts as strict, line-by-line instructions. Look at a sentence loaded with 6 synonyms and multiple dependent clauses. By the third turn of a live conversation, the model's interpretation of that complex text will drift. To prevent this, strip away the clauses. Replace narrative conditions with straightforward, single-action declarative sentences. If the caller asks for sales, transfer to sales. One line, one instruction, zero ambiguity. Engineers also frequently waste tokens defining standard industry concepts, like explaining what a voicemail or a transfer means. Foundational models already understand this terminology. Redefining common words merely clutters the processing pipeline. Another error is repeating the exact same routing rule under several different section headers in an attempt to enforce it. Human writers rarely repeat themselves identically. You might write the rule 4 times with slight phrasing variations. To a language model, those are 4 distinct rules. If they do not align perfectly, the AI is forced to weigh conflicting logic, resulting in erratic routing by the third turn of the call. Every line in your prompt must serve a distinct mechanical purpose. If a sentence does not definitively change the model's behavior, it is active interference. Delete it. Prompt writers often stack negative instructions, telling the agent, do not pick the first result, or do not transfer blindly. Compare that to a single positive command. Ask the caller to clarify. Telling the AI what to avoid leaves the required action entirely open-ended. When the model reaches a dead end without a designated next step, it attempts to fulfill the prompt by inventing its own answers. Affirmative logic provides a direct path to execution. This exactness becomes even more critical when deploying real-time voice architectures. Audio models process information differently than text-based chat interfaces. In live audio, the token economy is incredibly tight. Every excess word in your system prompt steals a token away from the model's capacity to actively listen to and process the caller's speech. You also must explicitly command auditory behaviors. If a caller stumbles over their words, or if there is loud background noise, the agent will guess how to react, and usually guess incorrectly, unless you provide strict instructions on handling messy audio. Voice AI requires aggressively brief prompts. You must preserve maximum processing bandwidth so the system can navigate real-time auditory cues without lagging. Sometimes, writing a highly complex prompt is actually a symptom of an underlying infrastructure problem. You might find yourself adding layer upon layer of text to force the AI to execute a rigidly defined workflow. If the intelligent agent struggles to follow a strict database lookup or routing tree, adding more aggressive phrasing will not fix the issue. You cannot effectively brute force structural limitations using natural language. In the 3CX AI Receptionist interface, focus on the Insert Variable dropdown. By selecting a pre-configured variable, like caller data, you delegate tasks directly to system tools, eliminating the need to parse natural language instructions. One variable replaces paragraphs of error-prone text. Offloading rigid step-by-step logic to system APIs and variables ensures execution happens deterministically. This frees the language model to focus entirely on managing the natural flow of the conversation. Before a prompt goes into production, it must achieve logical consistency. This means there is an absolute absence of overlapping or conflicting rules when the entire text is read sequentially. Finding those overlaps manually is extremely tedious, which brings us to one of the most efficient workflows in prompt engineering, using a large language model to audit and fix another AI system instructions. By converting strict prompt writing guidelines into a Markdown document and uploading it to the AI's knowledge base as a skill, you turn the model into an auditor. It will automatically review your drafts, flagging contradictions and unnecessary prose before you deploy. Finally, standard test scripts are effectively useless for quality assurance. You must test the agent using unpredictable, chaotic audio inputs, callers changing their minds mid-sentence, interrupting, and speaking over background noise. A ruthlessly edited, tool-integrated prompt written strictly as code is the foundational bedrock of the system. That exactness is what guarantees a stable, highly performant real-time voice agent on the 3CX platform.